In this problem, we need to convert the given rational fraction into partial fraction. Let's begin. First, before proceeding, we need to check that the degree of the numerator must be lesser than the degree of the denominator, which is true in our case, because if we look at the highest power of x in the numerator, that's 1, and the highest power of x in the denominator is 2. Now, all we have to do is we'll need to factorize the denominator, which is x squared plus 3x minus 18. So if we use standard techniques, then the factorization is going to be x plus 6 multiplied to x minus 3. So we have a rational fraction 2x minus 3 divided by x squared plus 3x minus 18. So this can be also expressed as 2x minus 3. Now the denominator will be expressed as the product of its factors, x plus 6 times x minus 3. Now the whole reason we have done is so that we can let 2x minus 3 divided by x plus 6 multiplied to x minus 3 as equals to the sum of two partial fractions, which will be a divided by x plus 6 plus b divided by x minus 3. Now a and b are some constants and we need to find out its value. To do that, all we have to do is consider the denominator of the expression on the left hand side, which is x plus 6 times x minus 3. We're going to multiply both sides of the equation with x plus 6 times x minus 3. We'll have to do that to the right hand side as well. We have x plus 6 multiplied to x minus 3. That means on the left hand side, we are now left with 2x minus 3. And then on the right hand side we have, so x plus 6 times x plus 6 gets factored out. We are left with x minus 3 multiplied to 8. This is going to be the first term, followed by x plus 6 multiplied to b. Now let's find out the value of a and b. So we can further reduce the right hand side of the equation as x times a minus 3 times a plus x times b plus 6 times b. We're going to compare on the right hand side all the terms containing x. We have x multiplied to a plus b, and we're also going to compare the constant terms. So that's the positive negative 3a plus 6b. Our task will be to compare the both sides of the equation. On comparing, we have the coefficient of x on the right hand side, that's a plus b. So that's equals to the coefficient of x on the left hand side, which is 2. Similarly, comparing the constant terms, so we have negative 3a plus 6b. So this is going to be equals to negative 3. Now what we can do, we can take negative 3 as the common factor. On the left hand side, we have negative 3 multiplied to a minus 2b. This is going to be equals to negative 3. So we can divide both sides by negative 3 to get a minus 2b. That will be equals to positive 1. So we have two equations, so let's label them. So a plus b equals to 2. We are going to label this as equation number 1, and a minus 2b equals to 1 is equation number 2. What we'll do, so we are going to take equation number 1, and from it we're going to subtract equation number 2. So let's do that. We should get a plus b minus a plus 2b, which will be equals to 2 minus 1. So a and a gets cancelled out. So we have 3b equals to 2 minus 1 will be 1, which means our b value, that's going to be 1 over 3, 1/3. So now that we have the value of b, we can use equation number 1 to obtain the value of a. So okay, and now using equation number 1, we have a value which will be equals to 2 minus b. That means we have 2 minus 1 over 3, which will be equals to 5/3. So we have obtained the value of a as well as b, which we can now replace in our assumption. This is our assumption, 2x minus 3 over x plus 6 times x minus 1, which was equals to a over x plus 6 plus b over x minus 3. So we will get a, which is a 5 over 3, all divided by x plus 6 plus the b value, which is 1/3 divided by x minus 3. So we can rewrite it as this will be equals to 5/3 multiplied to x1 over x plus 6 plus 1/3 multiplied to 1 over x minus 3. This is the final answer, and if we combine these two partial fractions, and we are going to get the original rational fraction.